One way to express a rational equation is by the definition of a rational function. In this case, the function is defined by the statement f of x equals x minus 5 over x. So this first piece here is our function definition. The second statement, f of x equals 4, is the equation that we want to solve. We always substitute from the function definition into the equation, or in some cases maybe an inequality. Never the other way around. We never plug into a definition. So what we would want to do here is replace f of x in our equation with the expression that is used to define it, which is x minus 5 over x, and then copy down the rest of the equation as is. There's next an equals sign, and on the right-hand side, the number 4. So I now have an equation that's written entirely algebraically, and therefore it's an equation that I know how to solve for x. This only has one denominator, and that denominator is x, and therefore my LCD is just x. Which means that in order to solve this equation, I'm going to multiply both sides of it by that LCD, which means multiplying both sides by x. We want to be sure to distribute this x into the brackets or parentheses and multiply it by both terms. X times x gives me x squared in this second product, x times 5 over x, the x's would cancel and all I have remaining is the 5. Over here on the right, nothing cancels out. There are no denominators, so I have the entire 4x still in that term. This step is actually a fairly common place for errors to occur. It's very common for students to accidentally have an x remaining in this 5 term and to lose the x from the 4 term. So we want to be very formal about what's happening in each of those products, just to be careful that we don't make that mistake. Now we want to get all terms on the same side, and this time I am going to choose to move my terms over to the left-hand side in order to keep that positive x squared term. So I will subtract that 4x to get x squared minus 4x minus 5 equals 0. This does factor as x minus 5, x plus 1, and then setting each of these factors equal to 0 gives me the two solutions, x equals positive 5 and x equals negative 1. The only value that is excluded from my domain I can see by looking at the LCD. Since my LCD only includes the factor x, my domain only excludes the value 0. If x is 0, then one of my denominators will equal 0 and I would get a division by 0 error. So neither of these is equal to 0 and therefore both are in my domain. I'm going to say my solution set consists of the two values 5 and negative 1. A good check to do on a problem like this is to not just plug back into the equation, but to go back to the original phrasing of the question. We were asked for inputs that would make the output equal to 4. So we can just see what happens if we evaluate f of 5. This would be a check. F of 5 is equal to 5 minus 5 over 5, which is equal to 5 minus 1, which is equal to 4, which is exactly what we were looking for in the original phrasing of this question, an input that would give an output equal to 4. Similarly, I can also check the value x equals negative 1 by plugging it in. and verify that I again get an output of 4. So both of these inputs give me an output of 4. Now if I want to go on to the question of what is a point on the graph of f, I can look back at these statements right here. This one tells me f of 5 equals 4, and this second one tells me f of -1 equals 4. Each of those is giving me an x and a y value. If x is -1, y is 4, so that would tell me that the point -1, 4 is a point on the graph of f. Or similarly, this is giving me an x and a y here, 5 and 4. So I could say that the point 5, 4 is also a point on the graph of f. So either of these would be a perfectly reasonable answer. What we do want to make sure we're aware of when we answer this question is that these two values that we found definitely do not make up an ordered pair. These are both x values. These are both inputs, so it would never make sense to put those together in an ordered pair. We can take one of these x's and put it with a y, but we would not put the two of these together.